Hello and welcome. In this video, we're going to review how to use the unit circle. So our goal in this lesson is going to be that we can evaluate the 6 trig functions given an angle on the unit circle. So let's go ahead and jump right in. So let's start off by listing some things that we should already know or be familiar with about the unit circle in general. So first of all, we want to remember that every coordinate on the unit circle is of the form cosine theta, comma, sine theta. So the x-coordinate is the cosine of theta and the y-coordinate is sine of theta. This is only true if the coordinate is on the unit circle. So if we look at problems from the previous lesson, if we were given the coordinate 2, 3, that doesn't apply because that's not on the unit circle. So every coordinate on the unit circle is of the form cosine theta, comma, sine theta, which means if we know x, we know what cosine of theta is, and if we know y, we know what sine of theta is. The next fact helps us use what we talked about in the first one to find tangent. So if we know that the x values are cosine and the y values are sine, and we know that tangent is sine divided by cosine, if we're given the coordinate on the unit circle, or we're given the angle, and we can identify its corresponding coordinate on the unit circle, we can identify sine, cosine, and tangent using these two facts alone. We also know that means we can take the reciprocals of each of these to find cosecant, secant, and cotangent as well. The next thing that I want to remind us is that 0 divided by 1 is equal to 0, versus if we have 1 or some other value in the numerator over 0, that is undefined. It's okay to have 0 of 1 of something. It's not okay to have 1 nothing. That doesn't make any sense. So if we're using coordinates on the unit circle that are actually on the axes, we're going to have a combination of 1s, negative 1s, and 0. So making sure you know the difference between when something is 0 and when something is undefined. Also, don't forget that you can use reference angles if we're being asked for an angle. You can use the angle that corresponds to that angle on the unit circle. You can use a reference angle to help you identify what we are talking about. And you'll see that come into play on some of our examples. And last but not least, something that can be helpful in a variety of different ways, but the basic trig identity that sine squared x plus cosine squared x equals 1, which comes from the whole idea of the unit circle in general. So now that we've reviewed these key items that we need to remember, let's go ahead and see how they apply to finding the exact value of a particular trig function. Okay, so here we have some examples where we're being asked to find just one trig function for a given angle theta. Now, if you have trouble remembering what coordinate corresponds to that angle on the unit circle, you should check out one of the videos reviewing the unit circle that relate to Algebra 2. Just go to the website and you can find it there. But I'm going to do my best to help review what you need to know here as well. If we're talking about sine of pi over 3, what we need to know is what is the coordinate at pi over 3. So here's where pi over 3 is. That coordinate is 1/2, comma, root 3 over 2. If we're just being asked for sine, we know that sine is the y-coordinate, which means that sine of pi over 3 is equal to root 3 over 2. If we're being asked for tangent of 7 pi over 4, so I'm going to figure out where 7 pi over 4 is. Here's 1 pi over 4, 2, 3, 4, 5, 6, 7. So here's 7 pi over 4, so I'm going to use this reference angle. This coordinate here is root 3 over 2, comma, negative 1/2. If we're looking for tangent, we're going to do sine divided by cosine. So that means here we're going to do negative 1/2, that's sine, divided by root 3 over 2. We know that with division of fractions, we can flip and multiply by the reciprocal. So this is going to give me negative 1 over root 3. Don't forget to rationalize your denominator. So this is going to be negative root 3 over 3. So tangent of 7 pi over 4 is negative root 3 over 3. Go ahead and pause the video and find cosine of 5 pi over 6 on your own, and then unpause the video and see how you did. So hopefully you had time to work through that. Cosine of 5 pi over 6 is going to be negative root 3 over 2. So pause the video, make notes of anything that maybe you had forgotten or you need to go back and review a little more, and then unpause the video as we move on to finding the 6 trig functions instead of just finding one. All right, so here we're given an angle, and this is in degrees. Typically, you're going to be getting angles in radians. Radians is the units that we choose to use in calculus, but we're going to go ahead and find the 6 trig function. So the first thing that we should do is identify the coordinate that this corresponds to. 270 degrees corresponds to the point 0, -1. So that means that sine of theta is going to be the y coordinate, which is -1. Cosecant is just the reciprocal of sine, so that is also -1. Cosine is going to be the x-coordinate, which is 0. Now we can't reciprocate 0, which means that secant of theta is not going to exist. So we're going to write DNE for does not exist, because we can't take the reciprocal of 0. Tangent of theta is sine divided by cosine, so -1 divided by 0. That is also not going to exist. Cotangent of theta is going to be the reciprocal of that, so 0 divided by -1, which is going to be 0. So I'm going to put 2 more examples up, and I'm going to encourage you to find those same 6 trig functions using those 2 angles. All right, here are 2 more examples. So pause the video, identify the coordinate that corresponds to your angle theta, and then work through this on your own. And then unpause the video and see how you did. And here you have the solutions. Make sure on the second one here for theta equals 5 pi over 3 that you have rationalized your denominator. So pause the video, check over these answers, write down any questions you have, and then we're going to look at one last set of examples. All right, I just wanted to give you the opportunity to have a few more practice problems. So here are 6 different problems that you're being asked to identify the trig value of, or the exact value of the trig function at that indicated angle. I encourage you to pause the video, work through each one, show as much work as you need to, and then unpause the video so that you can check over your answers. All right, here are the solutions to those 6 extra examples. So take your time, pause the video, check over each of them, and then we're going to wrap up. All right, let's recap what we covered in this video. Our goal in this video was that we would review and be able to evaluate the 6 trig functions given an angle on the unit circle. So we were able to review sine, cosine, tangent, and using those to find secant, cosecant, and cotangent. So go ahead and write down any questions you have, and I look forward to supporting you on this. Thanks for listening.